Bismillahirrahmanirrahim. So previously we were talking about so many things. We have talked about complex numbers, their geometrical representations. Then we have talked about De Moivre's theorem. Then we have talked about the notation e power I theta. And then now we will talk about the nth roots of unity, or like roots of unity. So the topic is roots of unity. We consider the equation. Consider the equation z cube is 1. This is easy to solve rewriting it by rewriting it. So we can rewrite, then this can be written as z cube minus 1 is 0. And if you factorize it, we can write z minus 1 into z square plus z plus 1 is 0. And we see that the roots are 1 minus 1 plus under root 3 iota over 2 minus 1 minus under root 3 iota over 2. These complex numbers have polar forms. These complex numbers have polar forms. So 1 is 1, minus 1 plus under root 3 iota over 2 is nothing but e power 2 pi iota over 3. Similarly, minus 1 minus under root 3 iota over 2 is e power 4 pi iota over 3. Okay. In other words, if we want to show this on the Argentine diagram, okay, then we can write this as okay. So this is e power 4 pi iota over 3. This is e power 2 pi iota over 3. And this is 1. Okay. These three complex numbers are called cube roots of unity. Or generally, if n is a positive integer, then the complex numbers that satisfy the equation are called nth roots of unity. for n in Z, then Z power n is equals to 1. For Z power n minus 1 is 0. Then roots of this equation are nth roots of unity. We have a proposition. 6.3. It says that let n be a positive integer and define w is e power 2 pi iota over n. Then the nth roots of unity are the n complex numbers 1 omega square omega power n minus 1, i.e. the similar notation we can write 1 e power 2 pi iota over n, e power 4 pi iota over n, e power 2 n minus 1 pi iota over n. They are evenly spaced around the unit circle. We can give the proof for this one too. So we say let z is r into e power I theta be an nth root of unity, then one is z power n, which is r power n e power I n theta. Okay. From proposition 6.2, part 2, it follows that r is 1 and n theta is 2k pi with k as an integer. Therefore, theta is 2k pi over n, and so z is e power 2k pi iota over n, which is w power k. Thus, every nth root of unity is a power of w. On the other hand, any power wk is an nth root of unity since k power n is wk power n k, which is e power 2 pi iota over n power k nk, which is 2 power e power 2 pi iota power k, which is 1. The complex numbers the complex numbers 1 omega square, or like w square, w power n minus 1, are all distant powers of w. Since w power n is 1, w power n plus 1 is w again. Hence, these are the nth roots of unity. This proves the proposition. Example: fourth roots of unity are 1 e power I pi by 2, e power I pi, e power 3i pi by 2, which are just one iota minus 1 minus iota. The sixth roots of unity are 1 e power I pi by 3 power I e power 2i pi by 3 minus 1 e power 4 I pi by 3 and e power 5i pi by 3. These are the corners of a regular hexagon drawn inside the unit circle. Let's try to draw this. Let's say we have this circle, and if we are able to get the shapes here somehow, so a hexagon I'm not sure this will be a proper one or not, but this we can try. So this has 1, 2, 3, 4, 5, 6, and you can say this is the center, and this line length is R. I need to remove this line and this line. Just connect these. So this is a hexagon which is driven in a very bad way, but like, and then all these. So let's say we have one here, and then we have e power I pi over 3, e power 2 I pi over 3, and this is -1. This is e power 4i pi over 3, and this is e power 5i pi over 3. This image is not that good looking, but okay, this increases and reduces, not tilted. So this is a bit tilted, but like, okay, can work. Okay. Now, let me just make sure that I am sharing my screen. Yeah. This is how we can draw that. We can use nth roots of unity to find the nth roots of any complex number, and that we can do. Now let's try and do an interesting exercise. this. Let Z is a complex number. We prove that 1 omega square, the 3 cube roots of unity, cube roots of unity not the unity but the cube roots of Z are the corners of an equilateral triangle. Let's first draw that. Let's assume that this is an equilateral triangle. Okay, or we can do this. Let's take this. What happened? Okay, this is a equilateral triangle, but like our circle is a bit tilted. Okay. Now we can see that we have 1 here, we have omega here, and then we have omega square here. Can we say that? And to see that, see, the solution says the 3 cube roots of unity one omega square are the corners of an equilateral triangle. Since you can easily take the distance between any of these is under root 3. So this distance is between any of these is under root 3. For the general complex number, z not equals to 0. For general complex number, z not equals to 0 if alpha is 1 cube root of unity of z, then the other are alpha omega and alpha omega square. Hence, the sides of the triangle they form all have length under root 3 mod of omega, mod of alpha, and so the triangle is again equilateral. So yeah, we can write that. We'll end this part over here. And then in the next chapter, we'll talk about polynomial equations. Thanks so much. Take care. Bye-bye.